As you can see in the agenda, we've broken the NetSuite track out here into two sessions. The first 30-40 minutes or so, I'm going to focus on the materials planning side of Intuiflow, and then on the second session, I'll be covering the S&OP piece of Intuiflow for NetSuite. And so I'm going to start by covering just some of the basics, just for those of you who might not be all that familiar with Intuiflow. Some of it's already been covered by, Chad and Deborah talked a lot about where DDMRP came from, but I'll cover more of that in the context of our product here in Intuiflow. And like I said, for the first session, I'm going to be focusing on the materials planning side, which is really going to be what's telling us on a day-to-day basis, what is it that I need to do? What are my priorities from a purchasing standpoint, production, distribution, things of that nature. And then later we'll get into the S&OP, which is where we can project out and plan for things in the future. So like Chad talked about quite a good bit earlier today, DDMRP is different from the traditional planning methodologies in that rather than planning specifically to a forecast, DDMRP is a consumption-driven model. The idea here is that we know forecasts are going to be wrong. If we forecast all the way at the highest level we can, we might be pretty accurate. Chad used his example of shirts. I might be able to say roughly how many t-shirts I'm going to sell over a given time period. But when we try to get more narrow than that, down to, all right, how many yellow mediums am I going to sell, it becomes a lot more difficult to forecast with any kind of accuracy. And so by planning to that specifically inaccurate signal, we end up with inventories being misaligned with what the actual market demand is. The idea behind DDMRP is that we can plan to actual consumption as it comes in from the market, because that's going to be a much more accurate demand signal. And so by trying to plan to that instead of that wrong forecast, we'll get our inventory levels, production levels, etc., much more in line with what that actual market demand is. So we can accurately support the demand with high service levels, etc., without having to carry a bunch of excess inventory to be able to do that. So there are, or the primary way we do this is by leveraging what are called DDMRP buffers, which are simply a dynamic stocking buffer that react throughout time based on the consumption that we see coming in from the market. As demand increases, these buffers thicken themselves, so we get the inventory that we need to be able to service that demand. Vice versa, if demand drops off, the buffers shrink down, so we don't end up with a bunch of excess inventory or waste that we end up having to write off at some point. There's three zones within the buffer. The core is the yellow zone, which is sized to cover our usage over the lead time. So on average, over a given lead time for an item, how much are we consuming? So we're obviously going to take the lead time into consideration for that. And then we want to take our rate of consumption into consideration as well. And there are multiple ways that we might arrive at that rate of consumption. The really standard DDMRP way is to use purely historical consumption, typically around 100 and 120 day rolling average, something like that. So over the past 120 days, how much have I consumed? Or on average, how much have I consumed over that time horizon? Multiply that by the lead time, and that gives us our yellow zone size. But that's not the only way that we can arrive at that consumption rate. There might be businesses that are really seasonal or have some product categories that are really seasonal. And in that instance, they need to, or it makes sense to incorporate a forecast into the sizing of the buffer. Different than the traditional method in that we're not planning specifically to that forecast, we're simply using it as a way to arrive at our average consumption that's going to size these buffer zones. Or we could take a a blend of the two. We could say maybe I want to use mostly historicals, but I still want to take some forecast into consideration. And so I might take 90 days historical, 30 days forecast, blend those two together to arrive at our consumption number or some kind of ratio therein. And so the yellow zone, size, cover, usage over the lead time. The red zone is the safety that's embedded within the buffer, and it's there to protect us against variation. Could be variation on the demand side, seasonality, things like that. Could be variation on the supply side, inconsistent lead times from our vendors, things of that nature. The more variation there is, the thicker the red zone needs to be to protect against that. Very similar in concept to the traditional safety stock, the big difference being the dynamic nature of these buffers. Most folks that we talk to that are using traditional MRP safety stocks, if they're doing a great job, they reevaluate safety stock levels on a quarterly basis. Most of the time, it's more like once a year, maybe twice. If you're doing that so infrequently, you're going to miss out most likely on trends in your consumption. So the fact that this is reacting to our fluctuating consumption on a daily basis helps us react to those trends much more quickly. And then the green zone is what sets our average order size as well as our ordering cadence. So frequently we'll use an MOQ to size the green zone. Frequently we'll use a desired order or replenishment cycle. Maybe I want to order from my suppliers on a weekly basis or a monthly basis or something like that. So we can size the green zone to adhere to that cadence. So we apply these buffers at the item location level, wherever we want to maintain strategic stocking levels. And then they dynamically adjust throughout time based on our fluctuating demand. Each one of these bars represents an individual day over time. So you can see how the buffer adjusts itself over time. And then we know when to place new supply orders and for how much based on what's called the net flow equation and where that falls within the buffer. The math is quite simple. Like Chad said earlier, we're doing 6th grade math here. That might be a little generous, maybe more like 3rd grade, depending on where you went to school. But the math is my current on-hand inventory plus any open supply minus any qualified demand. Demand is going to qualify if it's due to be fulfilled today or in the past. I know this says sales orders, but there could be various types of transactions that constitute demand. So it's demand due today or in the past, or what's called a qualified spike, which is firm demand that's due, firm demand already in the system that's due out in the future, but we want to go ahead and factor it into the equation today because it's due soon enough and the quantity is large enough. Typically, we would set that threshold to say if the demand is due within 1 lead time and the quantity is greater than or equal to 1/2 of the red zone. We have clients that adjust that. Some clients want to qualify if it's due in 2 lead times or if it's a full red zone. So there's flexibility there. But this net flow is basically a summary of everything that's flowing in and out of each location for each item. And then the way that it works is the net flow position starts out at the top of the green zone. Over time, as we consume materials, the net flow decreases with respect to the buffer. And once it drops out of the green zone into either the yellow or the red zone, that triggers an order recommendation, the quantity being enough to get that net flow back up to the top of the green zone. So over time, we should see our net flow fluctuating like so. And then we can also track our actual on-hand inventory levels and where those are fluctuating within the buffer. Just to see an example within NetSuite, here's a screenshot of an item in my demo site. So this is part PPJ at my plant location. Again, we apply these buffers at the item location level because if we have the same item at multiple locations, they might have different demand patterns, they might have different lead times, things like that. So we want to manage them independently. We can see on the left here, The buffer sizing shows how this buffer is sized as of today. So we can see the red, yellow, and green zone. The net flow is in blue here. We can see that that's in the yellow zone. So instantly upon looking at that, I've got an order recommended against this item today, right, to get that net flow back out of the yellow zone and up to the top of the green zone. And we can also see our current on-hand inventory. And then there's this little blue dot here. That's my expected average inventory or my target inventory levels. And Chad was talking about that a little bit earlier. Forget the acronym he used. Do you remember?
I think it's ITR.
ITR, right, ITR. So this is the expected average inventory, very similar idea. It's a simple calculation. It's our red zone plus 1/2 of the green zone. So on average, over time, that's where we should see our inventory fluctuating around. And because it's calculated based on the size of the buffer zones themselves, as my buffer resizes itself throughout time, that expected average inventory will resize itself as well. And we can see that over here on the right. This part analytics shows us a historical view of the buffer. In this case, I had set it for the last 6 months. So we can see over that 6-month time period how the buffer had resized itself. We can see that light blue line showing our expected average inventory fluctuating around time, and then our actual on-hand inventories are fluctuating nicely around that target inventory line. Now, as the buffer resizes over time, there's going to be times where my on-hand inventory drops down and consumes some of the red zone. That's perfectly fine. That's what the red zone is designed for. A lot of folks that are used to the traditional safety stock, that makes them a little uncomfortable at first, because the way that those traditional systems work, inventory hits the safety stock, drops below it, and they get a signal to replenish. And then if it hits it again, the next day they get another signal, and they end up with this really noisy system. So in the DDMRP method, the red zone is designed to be consumed, but we want to monitor it via this part analytics over time to make sure that we're not constantly living down in the red zone. It's occasionally dropping down in there, but over time fluctuating around this blue expected average inventory line. Any questions on any of that? No? No? Pretty familiar with it so far?
Yeah, you got ITR, there's nothing in Intuiflow for NetSuite that can show that, right?
I don't believe so.
What is I missed that part of
Inventory target ratio, the Chad talked about.
So it's a calculated ratio of
On hand divided by target.
Ah, that's right. It was, yeah, so it was on hand divided by this expected average inventory, I think. I don't think we have anything in like the Intuiflow record like we're looking at here.
You can create a search, like a custom formula, maybe get that ratio, if you wanted to do
So
a report.
to show it over time, what do you do? Do it every day?
To show it over time, technically, if you wanted to go really far, the graph there that's represented on the right, showing your analytics, is actually represented by a record called an Intuiflow Hart history record. If I'm not mistaken, you can find it in your custom records.
So that has all the data in it.
Exactly, and you can pull that data, and I've always said that's honestly probably some of your most valuable data, in the sense that NetSuite doesn't actually capture your like a snapshot of every day for your like parts in terms of inventory, open supply, open demand. And those records there, they have your open supply values, your open demand values, all the values that you can basically find on the Intuiflow record. Yeah. You can find all of them stored
by day.
by day going back in your history.
That's way different.
So not only can you do that, you can manifest that data into all kinds of really great stuff.
Yeah.
Measuring your performance of, your actual planners and seeing like, are they ordering actually every time your net flow hits the yellow? are they over ordering sometimes, is NetFlow, how often is NetFlow jumping up over the top of the grade?
Can you guys tell that Danny's more on the technical side than me? That's why I brought him here. So, that's being calculated every day in the background based on all of the data that's being transacted in NetSuite. You can see we've got these buttons here. So if, I've got an order recommended against this item today. So if I wanted to place an order, I could click create purchase order and it would generate that transaction. At which point you just work through it like any other transaction you work in NetSuite based on the processes and workflows you have established around those. There's a way to do that in mass as well. I'll get to that here in just a moment. But before that, I wanted to touch on the idea of strategic decoupling. And Deborah talked about this a lot, but it's the idea that we want to strategically place these buffers throughout your portfolio, throughout your bill of material or your distribution network, because not necessarily is every item going to have a dynamic buffer on it. Just depends on the nature of the items. You might have some slow movers where you want to have some in stock, but the dynamic nature of the buffer isn't the most appropriate way to manage those. And so more static min-max makes more sense. Or you might have, let's say, make to order finished goods because you do custom assemblies of your products or something along those lines. So we wouldn't buffer the finished goods because those are make to order. We're not keeping stock of them, but it makes sense to place buffers strategically throughout the bill of materials so you can protect your lead time commitments to your clients. Ensure you have the raw materials and intermediates on hand when you'll need them to be able to build those finished goods. And so wherever we place one of these buffers, we refer to that as a decoupling point. And what it's going to do, essentially, the buffers are designed to ensure constant material availability. So anywhere we have a buffer, I can assume I'm going to have that product or that item available when I need it. Now, life happens. There's going to be time to time when that's not the case. But for the most part, the buffers are going to protect that availability. And so because I can always count on that being available when I need it, I've decoupled myself from any upstream variability. So for example, if we apply a buffer at the raw material level, typically the lead time from our suppliers is the longest lead time that we have. Like Chad talked about earlier, the longer the lead time, the more at risk of variability we are. So it's very beneficial to place those buffers there to decouple us from that. And by placing them throughout the value stream, we can shorten our planning horizons, compress lead times, absorb variability, and the like. And so here is an example of that within a bill of material for a make part. So this is the finished good part FPA at the top of my bill of material, and then all of its intermediates and raw components going down through this bill of material. Any item that we see here with this red, yellow, green icon is a buffered part. So we're making FPA to stock. Any item that has a gray icon, that's what's called a non-buffered part. So it's either a make to order or a buy to order part. And then this part here, part PPA with this black circle around it, that's my longest non-buffered leg within the bill of material. So in this case, part PPA is a buy part that has a 25-day lead time. That's my longest non-buffered leg in this bill of material. Anytime I want to make FPA, first I have to order PPA, wait 25 days for it to get to me, and then I have the material that I need and I can make FPA, and part FPA has a 10-day manufactured lead time. So once I have all my components, it takes me 10 days to make FPA, but because we have that long non-buffered leg, 25 days for part PPA, that gives us a cumulative lead time, like Chad was talking about earlier, of 35 days. So when we come into this view in the software, and we can look at this in a little bit if you'd like, but we can then see the effect of what would happen if we made the financial commitment to start stocking PPA and apply a buffer to it. Well, then that would decouple us from this 25-day lead time, because once we have the buffer, we can assume we're going to have PPA available when we need it. So we no longer have to take that 25-day lead time into consideration. At that point, just because I know this example, part SAE with a 4-day lead time becomes my longest non-buffered leg. And so by buffering and keeping stock of this raw material, I can compress my lead time, if we do the math, from 35 days down to just 10 plus 4 days, so 14 total days. So we can shrink that cumulative lead time, making us more responsive to the market. What that's also going to mean, because the lead time is a factor in the buffer sizing, a shorter lead time means a smaller buffer because we can get it more rapidly. Therefore, we don't have to keep as much inventory on hand of my finished good to be able to satisfy the market or the demand coming in from the market. So protecting our service levels, compressing lead times, and dampening that variability. And then another thing, while we're on this example, so let's see this part PPJ here. We looked at that earlier. It's a buffered part. It's a raw material in this bill of material. It might be a component on 1,000 other bills of material. Maybe I'm in industrial manufacturing and PPJ is a screw, so it goes into everything. Well, the production of all of those 1,000 finished goods is all going to aggregate as the consumption against part PPJ for sizing its buffer. To go another step further, maybe we sell part PPJ as a replacement item or something like that. So in addition to the work orders that consume it via these bills of material, we've got sales orders that consume it. Maybe we distribute it out to forward locations, and so we've got transfer orders as well. So all of those different types of transactions will consolidate as the consumption that goes into the sizing of that part's buffer. Any questions on that? Nope. All right, great. So the 5 components of DDMRP, I'll skip over this really quickly. Positioning, that's that strategic decoupling. Assigning buffer profiles. So we have different buffer profiles that get assigned to different item types based on things like how long the lead times are, how variable the consumption is, etc. And those buffer profiles are going to impact how responsive the buffer is, particularly the red zone, to fluctuating demand. Let's say you've got thousands and thousands of items in your portfolio that we assign buffers to. Things are going to change with those items over time. And so while we apply buffer profiles initially, at some point down the road, we might need to make some adjustments there. So there's a tool in the software called the Smart Buffer Profiler that allows you to evaluate that en masse. We don't want you going item by item down 1,000 different items. Let the software do that evaluation for you. And if you're not familiar with that function, I can show you in the software where specifically it is and how it works. One of the benefits that I'm sure all of you know is prioritization. Here's the planner's workbench. This is going to show me, based on how deeply the net flow has penetrated an item's buffer, what the priority is. The deeper we penetrated, the higher priority it is for me to replenish. So anything in yellow or red needs to be replenished based on that net flow logic. If, for example, here's that part PPJ that we looked at earlier, it's got an order recommended against it today, but let's say for whatever reason, I don't accept that recommendation. My supplier was closed, the buyer was on their honeymoon for 2 weeks, whatever it is. As we keep consuming that material, that net flow is going to keep dropping lower and lower in the buffer. that item is going to keep moving higher and higher and higher. So clear prioritization, and then via the accept recommended orders window, very easy to accept on these recommendations in mass. I've got a generic example here where you can see I've got a slew of items that I'm approving replenishment for, different types of items. We can filter down as we want to, but we don't necessarily need to. I've got some purchase parts, make parts, and distributed parts in here. So if I wanted to, I could just select all of these items, click that generate orders button, and then Intuiflow would generate all of the corresponding transactions in mass to simply go through whatever approvals, processes, or workflows you guys have established around those transactions. Questions on that?
So right now, we have roughly 125 buffers.
Mhm.
Buffer profile.
Yep.
System. And they are set up with certain values as relates to the red zone safety,
Mhm.
red base safety, yellow zone
Mhm.
factors. Are those set based on a specific reason for that particular profile, or are they meant to be adjusted? You know, what's the thought behind the logic behind that?
So yeah, your buffer profile settings were set probably during your implementation. Really, they were generated out of, a lot of our consultants' experience kind of in looking at simulations over and over. And you can imagine, how many buffer profiles you say you have?
We have 125.
125. Doesn't actually, I think more buffer profiles is better because that allows for more differentiation among, from one part to another. And how those settings were chosen, obviously things with a higher buffer profiles that are assigned to parts with a higher variance are going to have a higher red zone safety factor. Ones with longer lead times are going to have a larger base factor. And however they get set, at the end of the day, the important thing is that over time, you continue to run SBP such that if parts variance changes, the parts variance changes over time, you want it to get assigned to a new buffer profile so that it gets those new settings. Does that make sense? And you want to do that continuously. So like, let's say you have a part that has a really high variance for the last year. And so it has a very volatile kind of demand history where, it's used a lot one month, used it less in another, it's not used for a month, got this really high variance. And then over the last let's say like the last 3 to 6 months, it starts to stabilize itself. And it's like now all of a sudden it's becoming a steady runner. You're using 10 units of that thing every day. Well, the variance has gone down. If you rerun Smart Buffer Profiler, get a new buffer profile with a lower red zone safety factor applied to it, and thus it would have a smaller red zone because you have a lower variance. You don't need as much protection in your red zone because all of a sudden this thing is turning to a steady runner.
Right, so that's part of what I was struggling with to understand now.
Mm-hmm.
Because if I take a look at this list of buffers, say for instance, there's a buffer, there's 114 days lead time, and the red base is set at 60%.
Mm-hmm.
Well, it's set at 60% for everything in that range.
Everything in that range, that's correct.
Whether it's low, medium, or high, it's set at 60%.
Yeah.
Is that where it's supposed to be? Or, is there supposed to be some difference? Between these?
Yeah.
I can change anything in there. Yeah, but the question is, what should I change it to?
Yeah.
Should I be changing?
I would say if you have 125 of them, like I said, you have 125 of them, you have a pretty, you have a pretty good set of
Definition page.
He might be saying 125 items, or do you have 125 different profiles?
125 profiles.
Okay.
Buffer profiles.
Buffer profile.
Buffer profile.
Yeah, like a B, you have a B11, B12, B13.
There's a full one, 11
to 55 probably.
35.
35, okay. So So you have, that means you have three lead
yeah,
time
that's-
factor ranges,
You
five,
probably just click on one of those there.
which is very common. And that's
Yeah.
okay.
Good.
Like I said, more of them is good because it leaves the ability for your parts to move in and out of them a little easier. And it, that means if your part even changes, if its variance goes down by a little bit, you rerun Smart Buffer Profiler, it'll pick a buffer profiler with a smaller red zone safety factor than the previous one. And, you'll be saving some capital investment on that part at that point. Or vice versa. All of a sudden, a part that's been a steady runner starts to see a volatile demand pattern coming into its history, and its variance goes up. You run Smart Buffer Profiler, it'll get a buffer profile with, like, instead of, let's say, a B11, maybe it'll move up to a B13, and maybe in another 3 months, it'll move up to a B15. And what that'll do is slowly over time, step up your red zone safety factor to accommodate that, that change in growth and variance.
Have you not changed your buffer profile since you've been running it?
Well, the ones that I have changed, are for distributed items, and I've adjusted the red zones to lower, how much safety, it's recommending.
I say, what I would do is, if you're trying to fix a singular part, I would try to do so by going in and changing the profile. If you're trying to fix a range of parts, like your distributed parts, you can go change all of the red zone safeties across all of the distributed profiles and bring them all collectively down.
When I would do that right there.
Yeah, well, if you're gonna do, so what I would not do is go change an individual profile. Because the profiles work in a kind of collective fashion that, like, especially stuff like their variance ranges, they have to be what we call mutually exclusive and collectively exhaustive PC. And what that means is that, you need a profile that covers the variance from 0 to 10, 10 to 20, 20 to something, and something to infinity. Because when Smart Buffer Profiler runs, your variance is going to have a value, and it needs to have a buffer profile to fall into.
Overlap.
Yeah, you can't, so they can't overlap, and they have to cover everything through what that means.
I think I'm gonna touch on it in a little while too, but I think you might wanna know, or I might wanna know, why are the presets set that way?
Yes,
So,
Right.
so the 1 goes from 0 to 100 in the variability. And the 2 is the 100 to 300 or 2 to 250. Maybe we're getting to that point where we want to understand how the gears in a watch work. How did they come up with that? Maybe it's just like, hey, past performance, all these thousands and hundreds of thousands of things worked into that.
yeah, and it's interesting because we'll touch on this tomorrow we're gonna kind of cover some of the ML stuff tomorrow, but in the ML stuff, we've actually really been focusing on what those values are. And yeah, we'll specifically be covering that topic.
But you're saying if you change the ones, then you don't just change E1, 1M, change all the ones. To be, if it was 60% red, change it to 50, or change it to 80, or change it to 20 on all those ones.
Yeah.
But obviously, want to make sure you're doing the right thing. Just not willy-nilly making a big adjustment that'll end up having an adverse effect 6 months from now.
If you're trying to, yeah, like I said, if you're trying to fix a singular part, instead of changing the profiles, go try to change the profile assigned to the part.
Right.
Another way to ask the question, how do you know when you need to change? What would you observe?
So,
How do you think?
well, we're going to get to S&OP here shortly in a second.
Mm-hmm.
And in our S&OP module, you can see, essentially a projection of how your buffers are going to look out in the future. And I've always said, well, if you're stocking out, if you see your projection stocking out, you need to make an adjustment to figure out a way to bring some. First, you need to assess why the stock out happened. Is it because there's a vendor shutting down for a month? Is it because you actually had a giant influx of demand in your forecast? What is it that happened? But one of the ways to fix a stock out would be to, pick a profile that perhaps provides more safety in it to bring it up. And vice versa, the other thing we look at is earlier was the idea that you want to see your buffers, your inventory dropping into your red zone. Are we good?
Yeah.
You want to see your inventory dropping into your red zone. If you never see your inventory line use your red zone, you're not using it. Like, and why do you have that inventory then? So I like to look at a percentage of red zone used, which basically says like what is the furthest you've ever dipped into your red zone over the course of a S&OP projection. And if it's something like 20%, that means you've only at max used 20% of your red zone. It means 80% of your red zone just sat on the shelf all year long. You can go adjust the profile down at that point to let it dip a little lower, and as low as you would feel comfortable at that point.
I always thought red was bad. So I've been geared towards,
I know, red is bad.
never go
So
into the.
You don't want your net flow getting into the red. Your inventory, sometimes you absolutely want it to use your
So on hand is okay.
Yeah.
Net flow does not.
Yeah.
I'm going to get the plug.
Yeah, so let's get
If
clear on
your
that.
inventory doesn't drop into your red, you are spending money to keep units on the shelf that you're never using.
But they're not, and net flow doesn't get it.
Yeah, that'd be
That'd be that.
Yep, so like what we can see on this part analytics here is our net flow is always fluctuating around that green and occasionally coming into the yellow zone, which is fine, but mostly staying up there. And then the on hand is what's coming down and occasionally dipping into the red, which is an okay thing. That's fine. Like Danny was saying, but we just don't want the net flow dipping into the red, because if the net flow gets down into the red, then the on hand is probably below the red.
So what's the sign of a healthy bubble? Where's that net flow trend?
The net flow should be fluctuating around throughout the green zone, because when that net flow drops out of the green zone, that's when we get a replenishment recommendation. And so perfect planning would be as soon as the net flow drops into the yellow zone, we approve the recommendation to get it back up to the top of the green. Now, again, like I said earlier, there's going to be context out there. So there might be very valid reasons why we didn't approve the replenishment as soon as it drops down into the yellow. But on average, we want that net flow to be in the green zone. And then our on hand should follow a similar pattern. So we've got similar sawtooths between the net flow and the actual on hand here. And we want that actual on hand to be sawtoothing around the expected average inventory, which is that light blue line there. It might be kind of hard to see on the projector. But occasionally we want to see the red or the on-hand inventory fluctuating around the low to mid part of the yellow zone, which is that target range. Chad was talking about the target range, which is the red zone plus the green zone, is where our on-hand would fluctuate in a perfect world. Now, we're not in a perfect world. That's why the red zone's there, so we have protection against variability.
All right, so if I'm gonna use the order cycle number setting, should I have values in both the cycle days and the green zone base percentage, or does it ignore one? So if I have 30-day order cycle, right? And I have 30% in the green zone base percentage, it's going to ignore the green zone base percentage. Is that what it does?
Correct.
It's only going to size every day. It's going to say, I need 30 times the ADU, and that'll be your green zone.
All right, let's keep moving along here, because we've got to leave time for Justin, and then he's going to be the last guy before we get into cocktail hour. So
Take as much time as you need.